Good morning dear students. I hope you are all well by staying at home. In last session we had seen we have started the lesson carbon and its compounds and the topics covered in previous class, introduction about the organic compounds and then characteristics of organic compounds, classification based on nature of bonding as well as nature of bonding and functional group, and then we had seen about the homologous series and its characteristics. Today in this class we are going to see about the nomenclature of organic compounds, how to name the organic compounds, and then what are the rules to be followed while we are naming the compound. What are the rules to be followed, that we are going to see in this session. First, in ancient days most of the organic compounds were extracted from the natural source. So most of the organic compounds were called in the name of its source. For example, the organic compound formic acid. The organic compound formic acid was extracted from red ant. So it was called as a formic acid. Why it was called as a formic acid means, formica means red ant. In Latin, formica means red ants. Since formic acid was extracted from the red ant, it was called by its source formica. From the source of formica, so it was called as a formic acid. But later, many organic compounds were synthesized in the laboratory. So finding the source and naming them was found to be difficult. So scientists decided to set certain rules for naming the compound based on their structure. So based on their structure, later it was named. For that certain rules were framed. That rules were authenticated by IUPAC, International. IUPAC means International Union for Pure and Applied Chemistry. What is the abbreviation for IUPAC? International Union for Pure and Applied Chemistry. That is the abbreviation of IUPAC. So certain rules for naming the compound based on the structure. Naming the compound based on structure, certain rules were framed. That rules were authenticated by the scientist and it was authorized by IUPAC. Now, while we are naming the compound based on structure, there are three components. So, what are the components of nomenclature? What are the three components of nomenclature means? First one, root word. Root word is the basic unit. This is the basic unit and it gives the carbon skeleton. Carbon skeleton, it describes the carbon skeleton. It is the basic unit and it describes this carbon skeleton and it gives the number of carbon atoms. Number of carbon atoms present in the chain, carbon skeleton. How many number of carbon atoms are present in the chain, and then what is the pattern of arrangement. So what are the things we will be learned from the root word? This is the basic unit. Root word is the basic unit and it describes the carbon skeleton. It describes the carbon skeleton and it gives the number of carbon atoms. How many carbon atoms are present? Number of carbon atoms in the carbon chain, carbon skeleton, and then how the atoms are arranged. How the atoms are arranged. The pattern of arrangement also will be given by the root word. So far, from the number 1 to 10, the number of carbon atoms which is linked in carbon chain from 1 to 10 was derived from the Greek numerals. For example, only one carbon, number of carbon atom. Only one carbon atom is there means we have to use the root word meth. If the carbon atoms, number of carbon atoms 2 means the root word used by us is eth. If the number of carbon atoms 3 means prop. And if the carbon atom, number of carbon atoms number of carbon atoms 4 means but. And if the number of carbon atoms 5 means pent. And if the number of carbon atoms 6 means hex. And if the carbon atom 7 means, number of carbon atoms 7 means the root word is hep. For the 8 oct, for 9 non, for 10 dec. So these are the root words used for the number of carbon atoms. Only one carbon atom in the carbon skeleton. If the carbon skeleton contains only one carbon atom means the root word used for that is meth. If the carbon skeleton contains 2 carbon atom means the root word used by us is eth. For the number of carbon atoms 3 it is prop, for 4 it is but, for 5 it is pent, for 6 it is hex, for 7 it is hept, for 8 it is oct, for 9 it is non, and 10 it is dec. So these are the root word used by us while we are using the carbon skeleton by based on the number of carbon atoms. And then the next one, prefix. Prefix is nothing but substituent or the branch. Substituent or branch. So prefix is nothing but prefix represents the substituent or branch that is linked with the carbon skeleton. What are the substituents or branch linked with the carbon atoms? That is prefix. Usually it will be an atom or number of atom. Prefix will be an atom or number of atom that will be linked with the carbon atom of the carbon chain, carbon skeleton. What are the prefix you will be using means for F fluoro. Fluorine is there means we have to use the substituent fluoro. Chlorine is there means we have to use chloro. And iodine is there means we have to use iodo. Bromine is there means we have to use bromo. And then for the case of methyl, CH3 we have to use methyl, and NH2 is there means we have to use amino. So these are the prefix that we are going to use when these substances are linked with a carbon atom other than hydrogen. And then the last one is suffix. Suffix is the end name. This is the end name of the carbon skeleton, that is organic compound. There are two kinds of suffix. One is primary and second one is secondary. The primary suffix will tell us about the nature of bonding. For example, single bond. Single bond means we have to use the primary suffix "-ane" for the single bond. For double bond we have to use "-ene." For triple bond we have to use "-ine." So these are the suffix, primary suffix. Only single bond is present between the carbon atom means we have to use the primary suffix "-ane." If double bond is present in between the carbon atom means we have to use "-ene." If triple bond is present in between the carbon atom means we have to use the primary suffix "-ine." Secondary word tells about the functional group. Functional group, for example, secondary group for functional group. Alcohol, this is OH present means we have to use OL, suffix we have to use OL. For COOH we have to use OIC acid. And CHO you have to use aldehyde, that means AL, the suffix used for a aldehyde is AL. For OH, OL, the suffix, secondary suffix used for that OL. For the COH, this is a carboxylic acid, so we have to use the secondary suffix OIC acid. CHO is there present means that that indicates the functional group of aldehyde. For that we have to use the suffix AL. So these are the components of nomenclature. Once again I am going to revise. There are three components. For naming the organic compound, we are going to use three components. One is root word, second one is a prefix, and third one is suffix. Prefix is nothing but that describes the carbon skeleton. That means the carbon skeleton contains how many number of carbon atoms. And then what about the pattern arrangement? That will be described by root word, and the root word is derived from the Greek numerals from 1 to 10 carbon atoms. Only one carbon atom methyl, like that it will be going up to 10. And then prefix represents the substituent or branch that is linked with the carbon atom except hydrogen atom. The carbon atom always connected with hydrogen atom except hydrogen atom. What are the substituents or branch that is linked with the carbon atom? That will be prefix. And some of the prefix I have described here. Fluorine is there means we have to use the prefix fluoro. Chlorine is there means we have to use the prefix chloro. And iodine is there, iodo. Bromine means bromo. And CH3 is there means methyl. And NH2 is there means amino. So these are the prefix we will be using. And then suffix is the end name of the carbon compound. We have two kinds of suffix, primary suffix and secondary suffix. Primary suffix will tell about the primary suffix tells about the nature of bonding. Single bond is there means we have to use the suffix ane, and double bond is there ene, triple bond is there means ine. And secondary suffix tells about the functional group. For OH is there means that is the functional group of alcohol. For that we have to use the secondary suffix OL. And COH is there means OIC acid. COH is the functional group of carboxylic acid, and CHO is the functional group of aldehyde. For that we have to use AL. Now what are the rules to be followed while we are naming the organic compound? Let us see this. First we have to identify the number of carbon atoms in the linear pattern, the maximum number of carbon atoms. We have to go for the chain which starts with the maximum number of carbon atoms. Here we have 1, 2, 3, 4, 5 carbon atoms. We have 5 carbon atoms. If 5 carbon atoms are there means the root word is pent. For the number of carbon atom 5, we have to use the root word pent. So this is a pent. And a prefix means the branch which is connected with the carbon atom. Branch which is connected with the carbon atom, but here we don't have any branches. No branches at all in this, so we need not to mind about the prefix. And then next suffix. Suffix in that first we have to go for primary suffix. Primary suffix will tell us about the nature of bonding. Here the carbon in between what bond is there? The single bond. Single bond is there means we have to use the primary suffix ane. So primary suffix is ane. And then next we have to connect the root word with the primary suffix and then with the secondary suffix. There is no functional group, so we need not to mind about the functional group. So what is the name of this compound? Organic compound means pentane. The root word and prefix and then suffix we have to add it. Here we don't have any prefix and we don't have any functional group, so we can add these two alone. This is pent, 5 carbon atom is there means the root word is pent, and the nature of bonding is single bond between the carbon atom, therefore ane. So we have to add this pent plus ane, pentane. So the first rule, we have to identify the number of carbon atoms in the carbon skeleton. That is the first one. Second one, we have to go for double bond or triple bond is there, and for double bond is there or functional group is there. For example, in this functional group OH is there, alcohol. OH is the functional group of alcohol. We have to look for that, whether the carbon chain contains double bond or triple bond or functional group or substituent. So first, in this one there is no prefix at all because there is no branch at all. If it is there any branch, we have to look at the branch. According to that, we have to use this word. Any branches it contains meant we have to use this. Example, in this branch is there. Branch is there. First we have to count the number of carbon atoms. Number the carbon atoms. We have to number the carbon atoms. For that we have to go for the longest carbon chain. Here when we start from here also the number of carbon atoms is the same. When we are going from this also we are getting the same number of carbon atoms. 1, 2, 3, 4, 5. In this also 1, 2, 3, 4, 5. So any one way we can go. And another CH3 we have to consider as a branch. This one we have to consider as a branch. This one we can, because in this way also the same number of carbon atoms, in this way also same number of carbon atoms. So we can take any one. So we can start the numbering of carbon atoms in any of the way. Let us see, we will go this side because both sides we are getting the same number of carbon atoms. So this is the first carbon, this is the second carbon, this is the third carbon, this is the fourth carbon, this is the fifth carbon. How I numbered the carbon atoms like this means, first we have to look at the branch. This is the branch, this is connected with the carbon atom. Sorry, here this is the branch that is connected with the carbon atom and with the substituent which is the closest end. This side it is not, it is too far away, the end is too far away from here, but here the end is the closest. So numbering of carbon atom we have to start with the closest carbon to the branch. This is the branch, this is the closest end, this is the far away, this end is far away from this branch. So numbering should start with the closest end to the branch. So to the branch this is the closest end. So we can start the numbering of carbon atom in this way. This is the first carbon, second carbon, third carbon, fourth carbon, fifth carbon. And then next one, what is the root word? If 5 carbon atom is there means the root word is pent. And then prefix is derived for a substituent. Here we have branch, substituent, methyl. Therefore CH3 is there. Therefore we have to use the prefix methyl. And then the local number. Numbering the carbon atom like this is called the local number. Which local number is getting the branch? Which local number is getting the branch? That we have to look at. The second carbon is getting the branch. That means substituent. The second carbon atom is getting the branch. Therefore, that also we have to mention. Prefix, only single bond is there. So, primary suffix is ane. First, we have to locate the substituent. Substituent is connected with the second carbon. Therefore, 2-methyl. Then root word followed by root word, pro, and then suffix. So 2-methyl propane. The name of the organic compound is 2-methyl propane. And then look at this. When we are looking at this, it has a branch. Here also is there, here also is there. When we are going in this way, the number of carbon atom is more. When we are going in this way, the number of carbon atom is less. Here 1, 2, 3, 4, 5, 6, 7. So this contains 7 carbon atom. When we are going in this way, 1, 2, 3, 4, 5, 6. So we should give up. The carbon skeleton should contain more number of carbon atom. So this is the right way. This is the correct way. And this is the wrong way. Numbering of carbon atom in this way is wrong because this chain contains more number of carbon atom. We have to go for maximum number of carbon atoms for root word. So this way is getting more number of carbon atoms. So we have to use the root word for this. 1, 2, 3, 4, 5, 6, 7. 7 carbon atoms are there means we have to use kept. So the root word is kept. The root word is kept. For 7 number of carbon atom, the root word used for 7 carbon atom is kept. And then prefix. Prefix means a branch. I said branch. This is the branch because we accounted already these carbon atoms, so this will be considered as a branch. And branch contains methyl. And then the branch is connected with which carbon atom? So we have to start from the lowest end. So this is the lowest end. Branch which is with this is the end far away from the branch. This is the end closest to the branch. So this is the first carbon, this is the second carbon, third carbon, fourth carbon, fifth carbon, sixth carbon, seventh carbon. Here the methyl group is attached with the third carbon. Therefore 3-methyl, because in third carbon the methyl is connected. So therefore this is a 3-methyl. And then what is the suffix? Primary suffix. First we have to go for a primary suffix. Since all the carbon atoms are connected by means of single bond. So what prefix is used means ane. And then the name of the compound is, first we have to give the preference to the prefix 3-methyl, then root word hept, and then suffix ane. So what is the name of this compound? 3-methyl heptane. The name of the compound is 3-methyl heptane. Now next we will be going for this. Here the functional group is there. The same rule we have to follow. The functional group attached, the carbon which is attached with the functional group should be numbered as the first one, because where the functional group is attached, that should be given lowest possible local number. So this is the functional group. From there we have to start the numbering. So this is the first carbon, this is the second carbon, this is the third carbon. So totally 3 carbon atom is there. Therefore the root word is 3 carbon atom is there means the root word is a prop. And then prefix will be denoting the branches. Here there is no branch at all. So we need not to mind about prefix. There is no prefix at all. And suffix, since it is primary suffix, first we have to go for a primary suffix. Primary suffix will be giving the nature of bonding. So the nature of bond is a single bond. So the primary suffix used here is ane. And then next we have to go for a secondary suffix. This is primary suffix. Primary suffix ane. And then the secondary suffix. Here what is the secondary suffix means we have to go for the functional group. The functional group alcohol is there. So the suffix used for alcohol is OL. And the OL is attached with the first carbon. I told that the functional group attached with the first carbon atom. Where the functional group is attached, that carbon must be given lowest local number. So this is the first carbon, this is second carbon, this is the third carbon. Therefore, how to name this organic compound means propane, and this E should be replaced by suffix OL, and OL is attached with the first carbon, therefore 1 OL. So propane 1 all. The name of the compound is propane 1 all. And then look at this. First we have to go for carbon skeleton, number of carbon atoms. Here it contains 2 carbon atoms. So the root word eth is used. If there are 2 carbon atom means the root word used for this is eth. And next we have to look for a prefix. There is no branch at all in this. So we need not to worry about branch. There is no branch at all, nil. And next we have to go for a suffix. Since all the carbon atoms are connected by means of single bond, the primary suffix is ane. And then next we have to look for a functional group. For secondary suffix we have to look for a functional group. Here COH is there. COH is the functional group of acid. Therefore we have to use OIC acid. So how to connect all this means? Eth, ane plus OIC acid. The primary suffix E should be replaced by the secondary suffix. Therefore ethanoic acid. This is the way of finding the nomenclature of organic compounds. Now we are going to see how alcohol is manufactured in the industry. Ethyl alcohol, this is ethyl alcohol, the molecular formula C2H5OH. How ethyl alcohol is prepared in the industry. Ethyl alcohol is commonly known as alcohol and it is used in beverages and then cough syrup. How it is prepared in the laboratory. We know that sugar is prepared from sugarcane. When they are taking the sugarcane to the industry, first they will crush it to make it as juice. When they are making the juice, the clear liquid stand above the tank is taken for crystallization of sugar. And for example, this is the tank. This contains the sugarcane juice. The clear liquid stand above. The clear liquid is taken for a crystallization of sugar. And then the bottom liquid with residue and mud, this is considered as a molasses. So the sugarcane is crushed into sugarcane juice. The clear liquid is taken for a crystallization of sugar. The bottom liquid that contains with mud sediments, that is called molasses. Molasses is the main source for the preparation of alcohol. Molasses contains 30% of sugar. This contains 30% of sugar. This is the raw material for the preparation of alcohol in industry. First one, I told that molasses contains 30% of the sugar. That sugar level should bring down by adding the water. So dilution is nothing but molasses with water. Molasses with water. The molasses is diluted with water to bring the sugar content. This contains 30%. Molasses contains 30%. When we are adding water with molasses, the sugar percentage will come down. That will become 8 to 10%. So for bring down the sugar level as 8 to 10% from 30%, we have to add water. That process is called dilution. So molasses is added with water to bring down the sugar content 8 to 10%. That is the first process, dilution. And then second process, addition of ammonium phosphate or ammonium sulfate. We know that all the agricultural products, whether it is rice, wheat or any of the agricultural products, that already contain nitrogenous matter. And sugar is also agricultural product, so that also sugarcane is also agricultural product, so that contain nitrogenous matter. But if the nitrogenous matter is not enough, is not sufficient for this process, means ammonium sulfate or ammonium phosphate, this will be added as a nitrogenous matter to enrich the nitrogenous matter. Already agricultural product contain nitrogenous matter. If it is not sufficient, the nitrogenous matter content is not sufficient in molasses, means the molasses is the ammonium sulfate or ammonium phosphate is added with the molasses to enrich the nitrogenous matter. Why we have to enrich the nitrogenous matter in molasses, means that will be act as food for the yeast. Yeast is the microorganism. We know that is very small in size. That is a microorganism. Yeast is the microorganism. So we are going to add yeast with the molasses. When we are adding the yeast microorganism, that needs food for segregating two enzymes. So this will be act as food for the yeast. These two will be act as food for the yeast. So ammonium sulfate and ammonium phosphate is added with the molasses to enrich the nitrogenous matter. That will be act as food for the yeast. And third process, fermentation. Now we are going to add yeast. After adding the yeast, the tank is kept for few days at 303 Kelvin. 303 Kelvin, the tank is kept for few days after adding the yeast. Now the fermentation process will take place. What is fermentation means? The complex molecule will be split up into smaller ones, that is called smaller molecule. Very big complex molecule is split up into simpler molecules, that is called a fermentation. Here sucrose is the complex. This is the sugar, I told you know, the chemical name of sugar is sucrose. And this is the molecular formula of the sucrose, C12H22O11. That is the molecular formula of sucrose. Sucrose is when we are diluting with water, this water, yeast is added. When we are adding the yeast will be segregating two enzymes. One is invertase and another one is a zymase. So yeast will be segregating two enzymes, invertase and zymase. The enzyme invertase will convert the sucrose into glucose and fructose. That will be splitting the macromolecule. This macromolecule will be split up into two simpler molecules. One is glucose and another one is a fructose. These two are isomers. Both are getting the same molecular formula, but the structure is different. Both are getting the same molecular formula. Though the same, both are getting same molecular formula, their structure is different. So these two are isomers. So one is glucose and another one is a fructose. And again the glucose, when it is acted by zymase, C6H12O6, glucose or fructose, when it is acted by the enzyme zymase, it is split up into ethyl alcohol. So zymase will be converting the glucose into ethyl alcohol, but this ethyl alcohol will be getting the alcohol percentage 5 to 18%. This contains only 15 to 18% of alcohol, remaining will be water. So this is called wash. The alcohol which contains 15 to 18% of the ethyl alcohol which contains 15 to 18% of alcohol is called a wash. This is technically called as a wash. Then wash contains only less percentage of alcohol. To enrich the alcohol percentage, the wash is subjected to fractional distillation. So when we are doing fractional distillation of what, it will be giving 95% of alcohol with 4-5% of water. This combination is called a rectified spirit. Yet we are not getting 100% alcohol. The wash is subjected to fractional distillation. Fractional distillation. The wash is subjected to fractional distillation. We will be getting the rectified spirit. The rectified spirit will be getting 95% of alcohol and 4.5% of water. This is not at 100%. To make it as 100%, the rectified spirit is subjected to reflux with the quicklime. Reflux with a quicklime. When we are doing reflux with a quicklime for 5 to 6 hours. When we are doing that with 5 to 6 hours and allowed to stand it for 12 hours. Reflux with the quicklime 5 to 6 hours. Then we have to keep the tank as such for 12 hours. We will be getting 100% alcohol. The 100% alcohol is called absolute alcohol. And next we are going to see physical property. This is alcohol is colorless, pleasant odor but burning taste. And then it is miscible with water in all proportion. And then the third property, the boiling point of alcohol is higher than the parent alkane. Which is the parent alkane of 2-carbon ethane. So ethyl alcohol boiling point is higher than ethane. So these are the three physical property: colorless but a pleasant odor with a burning taste, and then its boiling point is higher than that of a parent alkane, and third property, it is miscible with water in all proportion. That these are the three chemical properties of ethyl alcohol. Now we are going to see chemical property. First chemical property, dehydration. Hydration means adding water. Dehydration means removal of water. So what is the first property? Dehydration. When we are heating the alcohol with concentrated sulfuric acid, ethyl alcohol, when we are heating the ethyl alcohol with concentrated sulfuric acid at 443 Kelvin, we will be getting the water is removed. water molecule is removed, so we will be getting a multiple bond in between the carbon atom, so this is ethene. So ethene is the product. And then second one, reaction with the sodium. When ethyl alcohol reacts with the sodium, it forms sodium ethoxide. This is sodium ethoxide. So we are getting sodium ethoxide with the liberation of a hydrogen gas. And then third property, oxidation. When ethyl alcohol is treated with alkaline potassium permanganate or acidified potassium dichromate, or alkaline potassium permanganate, any one. When ethyl alcohol is treated with alkaline potassium permanganate or acidified potassium dichromate, it forms acetic acid. This is the alcohol, this is the test for alcohol. How we can do that means, the color of potassium dichromate is orange. When it reacts with the ethyl alcohol, when it is reacting with the ethyl alcohol, the orange color will be turned into green. In this way, the police is testing the person who consumed alcohol. They will ask them to blow their mouth. When they are blowing the air from their mouth, the potassium dichromate with orange color will be turned into green. So this is the test for alcohol. And then the fourth property is a dehydrogenation. Dehydrogenation means adding of hydrogen. Here dehydrogen means removal of hydrogen. So ethyl alcohol, the vapors of ethyl alcohol is passed over red hot copper at 573 Kelvin. Red hot copper, this is acting as a catalyst. This will not involve in chemical reaction. This will alter the rate of the reaction. So this will alter the rate of the reaction. So ethyl alcohol, the vapors of ethyl alcohol passed over red hot copper at 573 Kelvin will be getting acetaldehyde. So here hydrogen is removed, that's why it is called a dehydrogenation. And then the last property is a combustion. Ethyl alcohol, when it reacts with, when it burns in oxygen, it forms carbon dioxide and water. So these are the chemical properties of ethyl alcohol. Next we are going to see about the uses of ethyl alcohol. Ethyl alcohol is used in hand sanitizer, and then it is used for preparing rectified spirit. Rectified spirit means 95% of alcohol, 4.5% of water. And then methylated spirit. Methylated spirit means 95% alcohol and 5% methyl alcohol. So it is used for preparing rectified spirit, methylated spirit, and then power alcohol. Power alcohol means alcohol with petrol, that is called power alcohol, and denatured alcohol means alcohol with pyridine. So four products we are obtaining from the alcohol: rectified spirit, and then methylated spirit. Methylated spirit means alcohol with methanol. 95% alcohol with 5% methanol is called methylated spirit. Rectified spirit means 95.5% of alcohol with 4.5% of water, that is called rectified spirit. And third product, power alcohol. Alcohol with petrol is called power alcohol. And fourth product, denatured alcohol. Alcohol with pyridine. So these are the four products we are obtaining from the alcohol, and alcohol is used as a solvent for dyes, paints, etc. And this is used in hand sanitizer and medical wipes. For example, when doctor uses the thermometer for one person, when the same thing is used for next person, the thermometer should be dipped in alcohol, because alcohol is used as a medical wipe. So today in this class we had seen about how to name the organic compound by using the nomenclature, and then some of the examples I worked out in the class, how to name the organic compound by saying by using the root word, prefix and the suffix. And then next we had seen how the ethyl alcohol is prepared in the industry, and what are the physical properties of ethyl alcohol, and what are the chemical properties of ethyl alcohol, and what are the uses of ethyl alcohol. These are the things we had seen in this class.